Okay.
So good morning to one and all. I'm Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering, SNS College of Technology. Today we are going to discuss about the design thinking on a kernel input and output system. Let us see what is design thinking first. Yes, yourself, can you state me about what is design thinking?
Design thinking is a user-centered problem-solving methodology typically involves 5 stages. They are empathize, define, ideate, prototype, and test.
So the first stage is all about an empathize. Our students will discussing about empathize and
Hello everyone, today I am going to empathize on the topic of kernel input-output system. Kernel input-output system is nothing but it will control how the OS communicate with hardware components. First of all, the system developers are facing that every time.
I am B. Manigan and today I am going to speak about empathize. It's a conclusion and there's a requesting application for like documents while ensuring the hardwares like printers and disks. It faces a challenge to deal with a multiple demanding and using application to once it provides a task so it's left too long. It also readable to make a mistake like miscommunication with a device. This whole system will be crash and lost data.
Hello, I am Javed Nosha to define about kernel input and output system. Designing a kernel input system is a core part of operating system architecture. It acts as a bridge between user level application and hardware level device interfaces. Here's an overview of how such a system can be structured. A modularity, which separates hardware specific and hardware independent layers. Buffering, a temporary storage to accommodate speed difference between and reduce the output interfaces. And caching, shows frequent data and memory output and speed up the access when there is a need.
Start.
Here are some key points about kernel input and output. It acts as an intermediary between user application and hardware. Acts as an intermediary between user application and hardware. Handles device communication using device driver. Provides system calls. Supports buffering, caching, and error handling. Manages asynchronous and synchronous input-output operations. System developers need a consistent and effort way to interact with kernel input and output subsystem because the current interface are fragmented and hard to optimize.
Yes, next one.
So discussing about the test, the goal is to validate the prototype with users, and the test might include benchmarking performance overloads and to check the compatibility of the driver and getting feedback from the kernel developers. The example case is if you are redesigning a Linux like kernel's input-output systems, your GT-based solutions it might include provide a unified API for all input-output device and allow hot plugging of device without rebooting.
Don't see. Aaron, can you come out with a prototype about it?
My name is Aaron. I am going to discuss prototype. The main goal of prototype is to create a simplified version. There are many prototype examples and best of the examples are implement a minimal device driver framework, design a virtual system for interface of input output, create markups for debugging tools that virtualize input output.
Hello everyone, I am Madesh. Today I am going to tell about ideate. The goal of the ideate is to generate a creative solution. Ideas might include a modular input-output subsystem that auto-detects devices using plug and play, better user space interface, example through device or system in Linux, secure input-output permission and sandbox.
Hello everyone, I am Adina. So I would like to conclude, using design thinking technique to create the kernel input-output system means we have to focus on the developer and user needs for encouraging collaboration and validating ideas with rapid prototyping and testing. So it makes a traditionally technical domain or user-centric and adaptable.
Design thinking on kernel.
Hello everyone, myself Kavi Krishnan. Hence I am summarizing design thinking to kernel input-output subsystem. Applying design thinking to kernel input-output system designs shifts the focus from purely technical aspects to user-centric problem solving. It ensures that the system addresses real developer and user needs, promotes collaboration, and supports innovation through paid prototyping and feedback. This approach leads to more adaptable, accessible and maintainable input-output system, making complex kernels development more efficient and aligned with evolving hardware and usability demands.